So here's the first numerical, which reads like this. A woman starts from her home at 9 a.m., walks, so 9 a.m. is something really important that is given in the numerical, walks with a speed of 5 km per hour on a straight road. So this is a motion in a linear dimension, so motion along a straight line. This is only in one dimension. Walks up to her office, which is 2.5 kilometers away. So we know the distance from her home to the office, which is 2.5 kilometers away. So we have this data. She stays at the office up to 5 p.m. So this is another time that's being given. So she stays at her office till 5 p.m. and then she decides to return back by an auto with a speed of 25 km per hour. So what is the question involved here? What are we supposed to find out? Now, we are asked to choose suitable scales and plot the xt graph for motions. What do you mean by an xt graph? An xt graph is a position time graph. So you're being asked to plot the position of the woman at different instants of time. So we know 2 instants of time that are being given here. So you need to know her position at different instants of time ranging from 9 a.m. till 5 p.m. and then you can plot the graph. Now, this numerical is basically or can be basically solved using any of these equations of motion. So now our job is to find out which equations of motion can be used among the 3 that have been mentioned here. Now let's write down the data that we have. So what all do we have? It is given. What is all given? The woman is at her home when the time is 9 a.m. So that means the position of the woman, if I call it to be x0, is 0. If I call her home to be the origin, so our initial position is 0. When the time reads, let me call that initial time as t0, which is 9 a.m. She walks with a speed of 5 kilometers per hour on a straight road. So this is a motion along a straight road. So let me take that dimension as the x dimension. So I can call that becomes her initial velocity. So I can call that initial velocity as v0 x, which is 5 kilometer per hour. Now one question, now do we need to convert this into meter per second? Well, that is not required here in this case because it just says you have to choose suitable scales and then it doesn't really mention that you have to do it in meter per second. But generally whenever you are solving any numerical involving kilometer per hour, we usually convert it into meter per second, but not in this situation because we are just plotting a graph and you can still choose your scales as kilometer and then hour. So we can just leave it as such. So which means she is traveling with a constant speed. If it's a constant speed, this implies her acceleration along the x axis was 0 irrespective. So along the x axis was 0. She was traveling with a constant speed, constant velocity. Now, what is her final destination? What is her final position? Her final position is she reaches a distance of how much? She has to travel a distance of 2.5 kilometers. So therefore, what was the time when she reached this? So we have to find out the time t1 in this case, which is not given. So now you see, you know the value of x, you know the value of x0, you know the value of the initial velocity, and then you know the acceleration, which is 0. You have to calculate t. So which of these equations can be used? Can I use the very first equation, which is v is equal to v0 plus at? Do I know v? No, I do not know v. Well, do I know v0? Yes, I know. I do not know t. So this involves 2 unknowns, hence I cannot use this equation. Can I use the second equation? Again there are, see, this is unknown and this is 0. So you cannot use this equation either. So, the equation that can be used is equation number 3. So, using equation number 3 and substituting the values, you can easily find out the value of t. So, I use this equation, which is x minus x naught is equal to v naught into t plus half, that is ax square, ax into t square. So, x minus x naught, which is 2.5 minus 0, that is nothing but 2.5, that is equal to, this will be v naught x. So, v naught x is 5 kilometer per hour, and this is, we know the time, which is, sorry, we are trying to find out the time. So, we do not know the time, that is t1, and this is ax is 0. So, the entire thing becomes 0. So, now this will be 2.5 is equal to 5 t1. So, how much is t1? Very obviously, this is equal to 2.5 divided by 5. Now, since you have a decimal in the numerator, what you could do is, in order to remove the decimal, we have to multiply it by a number that has a single 0. Now, there is a decimal point after one digit. So, I multiply the numerator and the denominator by 10 by 10. 10 by 10 is nothing but 1. So, it is as good as writing 2.5 divided by 5. Why am I multiplying it by 10 by 10? Because you have a decimal point after one digit. So, you have to multiply it by a number that has got a single 0. So, upon multiplying, I get 250. Now, there is a decimal point. So, I keep the decimal point. So, this becomes 25 divided by 50. So, what is 25 divided by 50? 25 ones and 25 twos. So, this becomes half. So, this is in hour. So, t1 is half hour. Now, I have to convert this into minute. So, this becomes half. 1 hour is 60 minutes. So, I multiply this by 60. So, this becomes 30. So, this is 30 minutes. So, she takes 30 minutes to reach a distance of 2.5 kilometers. So, she's t naught was how much? 9 a.m. So, t1 will be t naught plus 30, which is nothing but 9 plus this 30 minutes. So, this will be in hour and this is in minute. So, this is nothing but 9 hours and 30 minutes. So, she takes exactly 30 minutes to reach her office if she is traveling with a speed of 2.5, if she is traveling with a speed of 5 kilometer per hour. Now, what does the second part of the numerical say? The second part of the numerical says she is in the office till 5 p.m. and she returns back home with an auto with a speed of 25 kilometers per hour. So, what are the other situations that we have in this numerical? Now, let me call this as the first case. So, we will take up the second case. Given what all do you have? We know that when the time was 9:30 a.m. the woman was at a distance of x is equal to 2.5 kilometers and she stays there, and when the time was 5 p.m. still the position of x was 2.5 kilometers. Now, She returns back to home. So, the position of x will be 0. When the position of x is 0, how much time does she take if she travels with the speed of 25 kilometers per hour. So, this is her initial speed, in this case 25 kilometers per hour along the x direction. Since it is a constant speed, again the acceleration along the x axis is 0 in this case. Now, using the same equation, I have x minus x naught is equal to v naught x into t plus half a x t square. So, this is again 2.5. She covers the same distance from her office to home, but now she is traveling with a different speed. She is traveling with the speed of 25 kilometers per hour in an auto. We have to calculate time. This is again 0 because Ax is 0. So, now this will be 25t is equal to 2.5. Therefore, t is equal to 2.5 divided by 25. Now, in order to remove the decimal, if I multiply the numerator and the denominator by 10 by 10, I get 250. I keep the decimal point after one digit. So, if I multiply this becomes 250. So, this is nothing but 25 divided by 250, which is nothing but 25 ones are and 25 tens are. So, t will be 1 by 10th of an hour. So, how much is 1 by 10th of an hour? 1 hour is 60 minutes. Now, if you multiply that by 60 minutes, so you have 6 minutes. She takes just 6 minutes to reach her home in an auto. So, this is her new time. So, this is T1, which we have calculated now. Now, we have to choose a suitable scale and then we have to plot the graph. So, let us plot the graph. So, I take the position, which is the x axis here, and this is the time axis. So, x is in kilometers and t is in hours. So, this becomes the origin. What is the value of? Now, before I plot the graph, let me choose a suitable scale. Now, for scale along the x axis, I take 1 centimeter. We know that each block will measure 1 centimeter. 1 centimeter. Now, what are the values of x and t? Let us write them first here. So, t and x. When t was 9 a.m., she was, what was the position of x? 0. When it was 9:30, it was 2.5 kilometers away. She reached her office. Now, again, when it was 10, 11 and all that till 5. So, when it was 5 p.m., still her position was 2.5 kilometers, whereas when it was 5.06 p.m., that is 5 hours 6 minutes elapsed, she came back to her home, which was 0. So, now I need to plot the values 0 to 2.5. So, this is the range of values that I will need on my x axis. Now, if I just choose it to be say 1 centimeter is equal to 1 kilometer, then my scale would something look like this. If this is 0, this becomes 1 kilometer, then I will have 2 kilometers, then 3 kilometers. Then you see that the graph was really small. It becomes really a very small graph. So, I need an enlarged one. So, for that I choose the scale as 1 centimeter is equal to, let us say, 0.5 kilometers, so that we have a larger and a bigger graph. So, this becomes, so the value of x is 0. I have taken the value of x as 0. So, this will be 0.5 kilometers. this is 1.0 kilometers, then this will be 1.5. So, you go on adding 0.5. So, 1.5 plus 0.5 because each centimeter is 0.5 kilometer. So, this becomes 2.0 kilometer and then this becomes 2.5 kilometers, which is what I exactly need, right. Now, I have to choose a scale for the time axis, the y axis, which is the time axis in this case. So, here also 1 centimeter is equal to. Now, you see for time I have to show from 9 a.m. to 5:06 p.m. So, you can either choose to start from, let us say 0, then 1, 2, 3, then 9 a.m., then probably this scale would not be enough. I would need a bigger paper and so what I would do is I would take 1 centimeter is equal to 1 hour, but I will not start the origin from O 0, I will take the origin of the x axis as on this axis as 9. So, I take this as 9 a.m. So, what are the coordinates of x comma y here? The coordinates of x comma y at the origin are 0 comma 9. So, I take this position as 9 a.m. So, now then this will be 10 a.m., this will be 11, this is going to be 12 p.m. So, this is 1 p.m., this becomes 2 p.m. So, this is 3 p.m., this becomes 4 p.m., this is 5 and this is 6. This is what I need and it fits into my graph exactly. So, now let's get going and let's plot the value. So, what was the value of x when the time was 9 a.m.? When the time was 9, the value of x was 0. So, this is actually the position of the woman when the time was 9 a.m. Now, when the time is 9:30, she is at a distance of 2.5 kilometers. So, 9:30 is somewhere here. So, if I plot this is her position at. So, this is what are the values? What is the value of x? This is 2.5 comma 9:30. These are the values of x and y. Now, she stays at her office till 5 p.m. So, when it is 10 o'clock, what is her position? It is again the same. So, it is again the same till 5 p.m. So, till 5 p.m. you can just show the value of x as 2.5 kilometers. So, you can show that by a dotted line. So, these are the values at 5 p.m. So, the value of x is 2.5 kilometers at 5 p.m. So, these are the values of x. Now, what is the value of x when it is 5.06? So, when the time is 6 minutes elapsed 5 p.m. So, I can just let us say this is 5.6. So, this will be her position. She will come back. So, this is the value, which is the value of x is 0 comma 5.06. Now, these can be shown. So, this can be shown by straight line. So, this is her position. So, this becomes the graph. So, this is the graph for the given numerical, where x is in kilometer and time is in hour.